All right, so we got part two of our slope lesson. Think of slope as the steepness of a line, but also as the rate of change, okay? The rate of change, how the y variable is changing related to the x value. Now, if we were to find how things change, let's say your score on a test, you took a retake and you got an 80, and then you got a 92. All right, how do you find the change in your score? Okay, you can, I mean, that's an easy enough problem. You can just kind of count up 80 to 92 is 12, but you can also use subtraction. All right, to find change, we can use subtraction. To find change, we can use subtraction. All right, last year I got 5 presents for Christmas. This year I got 14 presents for Christmas. What's the change? Well, I could do 14 minus 5. Okay, so change we've talked about a lot. Slope and rate of change is just the change in y over the change in x. All right, so now we're going to take that idea and we're going to extend it and build a formula. And this formula is called the slope formula. Okay, so the slope m, we haven't really talked about that. That letter that people often use for slope. Okay, this variable m it's often used to indicate that you're finding slope. And I think one of the things I heard was that it's from a French word for climb, montar, like mountain, but montar, French word for climb. And slope, is like a mountain, like the steepness of something. So to climb is montar. So anyway, so the slope m of a line passing through points x1, y1, and x2, y2. Now, these are just coordinate pairs, okay? And the little subscript here, these little ones here, mean the first point you chose. And these little twos, that just means the second point, okay? The second coordinate pair, all right? So the slope m of a line passing through these 2 points is the ratio of the difference. Remember, we heard the difference. We talked about the difference, how finding the difference is actually finding how something changes. Okay, the difference in the y coordinates, so that's saying the change in the y, to the difference in the x coordinates, so that's the change in the x coordinates. So the ratio of the difference of the y's and the difference of the x's. Very similar. It's exactly the same as what we've been doing. It's just a different way to apply it. Okay, so what does this m stand for? That stands for slope. Okay, and the difference in the y coordinates is just saying the change in y. All right, and the difference in the x coordinates is simply saying the change in the x coordinates. Okay, the change in x. So this is just another way to find the rate of change. All right. Now, this is just a general picture. Lines could be going different directions. They could be flat. Okay, they can be all sorts of different angles on this. But the key is that we just have to choose 2 points, any 2 points, and we're going to label them x1, y1 for the first point, the one furthest left, and we have to label the other point x2, y2. All right. So like I put right here, it's just a fancy way to find the constant rate of change. All right, let's get into the actual steps here. Using slope formula to find the slope for a linear relationship. Now remember, slope is just rate of change. So if we just look at this table here and we see that it looks like when the x goes up by 1, the y goes up by 4. And let's see if that's constant. 1, 4, 1, 4, 1, 4. Yes, it is. Okay. So the constant rate of change is a fraction, right? 4 over 1, 4 over 1, 4 over 1, 4 over 1. It's constant when we divide those changes. So the constant rate of change is 4. The slope is 4 because they're talking about the same thing. Now that we know that, we're going to extend it and see if this slope formula makes sense. So step 1 is write 2 points as coordinate pairs. So this is a coordinate pair, this is a coordinate pair, this is a coordinate pair, right? This and this. These are all coordinate pairs. We just have to pick two of those. Okay, so let's pick, doesn't matter which two, 1 comma 12 and let's say 3 comma 20. Any 2 points. Now you're going to label them x1, y1 and x2, y2. Okay, so let's call this, x1, y1. Okay, I just wrote it underneath it. So now 1 is x1 and the 12 is the y1. Okay, and now since this is my second point I chose, I'm going to call the 3x2 and the 20 y2. Okay, the first x coordinate I chose and the first y coordinate I chose. The second x coordinate I chose, the second y coordinate I chose. Okay, and now once we've labeled them x1, y1 and x2, y2, now we're just going to substitute into our formula. So we have the slope equals the difference in the y's over the difference in the x's. All right, so we're going to replace y2 with, well, which one of these is y2? I labeled the 20 y2. Okay, minus y1. y1 is 12. All right, so see, you have the difference in the y's, or how are those y's changing? It went from 12 up to 20. So look, 20 minus 12 is 8. It changed by 8. All right, and now we're going to fill in the other part. So we have we're looking for x squared in our formula. It's not x squared, sorry, x2. So we go find x2 here, and that's a 3. Now, we're going to go and find, because the formula says x1, we're going to find x1, what we labeled, and it's a 1. So now, 20 minus 12, we're going to simplify and get 8. 3 minus 1 is 2. It might not seem like that same constant rate that we got, but when we simplify it, it equals that 4 over 1. What does that mean? That means y changes 4 for every 1 change of x. Y changes 4 every time x changes 1. It's a ratio or rate of change. How are they changing together in relation to each other? All right, so now let's try to use that slope formula. Slope formula, m equals y2 minus y1, the change in y over the change in x. Okay, you'll memorize this after we've had so much practice. Now, sometimes you'll have the information in a table. Sometimes it'll be in a graph. Sometimes they'll just tell you that here are 2 points. All right, 2 comma negative 1 and 5 comma negative 6. They'll just give you 2 points and they'll say, find the slope of a line that passes through these 2 points. Okay, so what does that mean? That means if you plot these two and take a straight edge and draw it right through those dots, okay, they want you to find the slope of that, or the pitch, or the steepness of that. Also, same thing as the rate of change. So what we're going to do here, what's our first step? Well, choose our 2 points. They gave us the 2 points. Second step, label them. First point, x1, y1. The second point, x2, y2. Now we just simply substitute into the formula. So we got y2 minus y1, x2 minus x1. Well, we're going to replace the y2 with what I labeled y2, minus 6. And I'm going to subtract. Now I go to y1 right here. That's going to subtract a negative 1. Careful with your signs here. Now, x2, I'll look up here. It's a 5. Subtract from that x1, which is 2. Now, what do we get here? Negative 6 minus a negative is going to be plus. So negative 6 plus 1, that's going to be negative 5. Over 5 minus 2, it's going to be 3. So our slope is going to be negative 5 thirds. So that means the y drops. You're going to be dropping 5 every time you go over 3 for x. Drop 5 over 3. Okay, so it'd be drop 5 over 3, drop 5 over 3, drop 5 over 3, making a line with that slope. All right. So it was a kind of fairly quick lesson. Try this one. Try this one, and on the Edpuzzle, fill in your answer. So find the slope between these 2 points. Okay, so if a line passed between these 2 points, you plotted these coordinate pairs on the graph, put a dot for each of them, and then you drew a line through it and found the slope between that slope of that line. Let's say we got 5, 2 and 10, 32. All right, find the slope of that line that passes through those 2 points. Good luck. Hopefully, this isn't too bad.